Hey guys, let's look at these last couple of examples real quick. Let's multiply this out and see what we get. E to the x times e to the x. And then e to the x times 6 becomes plus 6 times e to the x minus 2e to the x minus 12 less than or equal to 3e to the x. Here I'm going to get e to the 2x. These are going to become plus 4 e to the x's. I can move this guy over to the other side. Minus 3 e to the x minus 12. Once I start to kind of look at this a little bit closer, I'm seeing that I have a term that is doubled, squared, and a term that is linear. So for me, just because of the way I like to look at these, I'm going to let e to the x equal some term t, and I'm going to replace that in all of our equations. So e to the x 2 would be t squared. This term right here is going to become 1 e to the x, so I have 1t minus 12 less than or equal to 0. All right, so let's factor that. So this must be t plus 4, t minus 3. So my two roots are going to be t is equal to negative 4 and t is equal to 3. All right. So remember, this is not our actual, right? It's actually this. So e to the x, e to the x. Now let's focus in with our replaced value. Okay. So e to the x can equal 3 because I can do that. There's some number that can be plugged in that'll give me 3. There's nothing that I can raise e to that's going to give me a negative 4. So this is not a possible solution because of the domain restrictions. So e to the x, come back over here, equals 3, and I can take the natural log of both sides. The natural log of e to the x equals the natural log of 3. So this quantity becomes x equals the natural log of 3. So now the question is it actually greater than or less than 0? So let's try the test point strategy again. Let's do 1 and I don't know, 9. We're going to plug in those numbers up here and see if that's true. I'm going to grab my calculator. E to the 1 quantity, e to the 1 minus 2 quantity times e to the 1 plus 6, enter, and then check over here. 3 times e to the 1. So is that true? Yeah. So we chose x is less than that, so that was a true statement. So when x is less than the natural log of 3, we get a true statement. Okay. Oop, I almost forgot to limit my domain. There we go. Now it's limited. This one right here, I'm going to get you started, and then I want you to work it out on your own. We're going to do this one as our must-do when we come to class tomorrow. I have a log base 7, a log base 2, and an 8. yucky. I can't put these together because this one has a 7 and this one has a 2, so I can't use the product rule. So I'm going to rewrite this as log base 7 of 2x equals, going to rewrite 8 as log base 2 of something equals 8. What is that number going to be? So you're going to rewrite that 8 as something else in terms of log base 2. So we're going to have log base 2 of something instead of 8 minus log base 2 of 4x. We're going to have to make this into one term, and then remember we have to choose what value we're going to be exponentiating. So we're going to finish this problem, so you're going to try it on your own, and then when we come to class tomorrow, this is our must do when we come into the class. So we're going to go through this when we start class tomorrow. Got your hint there? So get started.